in chapter 22. I've been telling you this is coming, that from now on, our chapters are going to include two things: confidence intervals and hypothesis tests. I was not lying. So we already have chapter 18 through 21 is the basis of knowledge you need to know to do every single chapter from here on out. If you don't understand the stuff in chapter 18 through 21, you need to see me pronto and get that remedied because it's not going away. Like I know how before you could have thought that like stuff was going away, especially we were done sort of with it. Not anymore. It's just gonna keep hitting you over and over and over again. So in chapter 18 through 21, we're generally talking about one proportion. Well, now we're talking about two proportions. All right. Now, when I say two proportions, I do not mean, because some of you guys are probably like, well, we've had two proportions. They gave us a p hat and a p, and we did this and whatever. That's not what I'm talking about. I'm saying we have two completely separate groups and we're comparing them. So, for example, I want to know the percent of people that are wearing blue in school today. I think it's different for the boys and the girls, right? But I'm going to find the percentage of girls wearing blue in my sample, the percentage of boys wearing blue in my sample, right? So two separate percentages. I want to compare those. That's what I'm talking about, two proportions. Like we actually have two separate groups, two separate proportions. Okay? Yes? All right, so we're going to start from the beginning. In order to do a hypothesis test or a confidence interval, what do you always do first? Check your conditions. So we have some conditions. They're very similar. The problem is you have two groups, so you got to make sure you check the conditions for both groups. So independence assumption still exists, right? So randomization. Both of the groups have to be random samples or a good representation of their populations, right? If I'm going to go see the proportion of people that are wearing blue in school today, then maybe I do a simple random sample of the boys and a simple random sample of the girls, but I've randomly sampled in both groups. So you need to say that. You need to say that both groups were selected at random or whatever. Both groups, keyword. The 10% condition. Both groups, their sample sizes, because they can be different. I could sample 112 girls and then 133 boys or something. I don't know. Both of your samples have to be less than 10% of the population. Right? So you have to say both of those. You can't just say one. Both of them. And now I'm throwing in a new condition. We have to have independent groups. So somewhere in your conditions and assumptions, you need to say that these groups are independent of each other. All right? So should the boys and the girls in the school influence the way each other dress in any way, shape, or form? Probably not. So they would be independent groups. If it was Spirit Week and everyone was supposed to wear blue on a certain day, would they be independent then? No. But so make sure you're talking about that their groups are independent of each other. That is key. That's the one new thing I'm throwing at you. Okay? Okay. Now, what's our other assumption? We've only talked about half of our assumptions. What's our other assumption? Sample size. So we still have success failure because we're still talking about proportions, but you have to do success failure for each group. All right? Each group individually. So if you have, again, two different sample sizes, you're going to have two different percentages. You have to do that both, each group. Okay. Anyone questions about the conditions? All right. So in order to do a test or a interval, right, you have to have a sampling distribution model to base it on, right? We always say we can use a normal model because we can use our sampling distribution model we talked about in chapter 18. So you got to have that here too. You can't just make it up, all right? In this case, we're talking always about the difference between the two proportions. right? That's the easiest way to compare them, is if you subtract them, you can see the difference. That makes sense, right? All right, so your sampling distribution model is going to be normal still. That's nice. We know all about normal models. Perfect. The mean, the center, right, what we expect the difference to be, is always P1 minus P2, the proportion for the first group minus the portion of the second group. But then we have to have a standard deviation, right? Okay, so here's our standard deviation. That's pretty much the same standard deviation formula we've been using, just twice. But we're doing differences, so why is there a plus sign in the middle? You can't subtract standard deviations or variances. We never do, ever, right? That goes back to chapter 16, where we always add them. Right? If you're putting two groups together, or they're adding or subtracting them, you're going to have just more variation. You're not ever getting rid of variation. So we're adding, right? So that's what you're going to use. That is on the formula sheet, just like it always is. It says 2 samples. Specifically, it says the difference of sample proportion, and then it gives you the formula, right? So no big deal, right? All right, so questions about that? Okay. After we did sampling distribution models, and what do we do next? Talk about confidence intervals, right? So guess what we're going to do today? Talk about a confidence interval. I'll remind you, when we first talked about confidence intervals, right, what was its quote-unquote formula for a 1 proportion z interval? P hat plus or minus the z critical value times the standard error, right? And I said on the AP formula sheet, it's written out in words, and it has statistic plus or minus critical value times standard deviation of statistic, which means standard error, right? Well, the same thing is happening here, but our statistic is different, right? Our statistic is no longer just p hat by itself. What is our statistic going to be? P hat 1 minus p hat 2. Plus or minus, are we still using a normal model? So then we're still using a z critical value. That doesn't change. If you're 95% confident, you're still using 1.96. And so on and so forth. And then the standard error, why do we call it the standard error instead of the standard deviation? We're talking about confidence intervals. Because you're using p hat. It's an estimate, right? It's not an actual p. So that formula is going to look just like the one on the screen, right? It's just going to have p hats in it and q hats, right? That should not be shocking or surprising to anyone about this, right? So here is your, I'm going to put it up on the screen. One more thing, let's see if you can guess, because you're doing so great today. What did we call an confidence interval for 1 proportion? What was the name? 1 proportion z interval for the interval. So what do you think we're going to call it for 2 proportions? A 2 proportion z interval. It's crazy shocking, I know. I know, right? No one could have predicted that. So here is your formula. We just talked this through, though, right? I mean, we just said this. I mean, you guys already kind of knew what was going to happen. So in the process of doing an interval, you have to follow the same steps you did before. Check your condition. You're getting better about checking your conditions because you realize if you forget them, then I'm going to take points off. So check your conditions. Then you did all the mechanics, right? You filled all the numbers in and you actually found the interval, right? Then in chapter 20, we started talking about hypothesis tests. I said after the conditions, you should make a statement. So from now on, after the conditions, we're always going to make a statement. Whether we're doing an interval or a test, we're always going to make a statement. We can use our normal model, and you can either name the interval or name the test. No big deal. Okay, so we're going to do that too. And then for 1 proportion z intervals, we had a conclusion statement that was something along the lines of, I'm 95% confident that the true proportion of whatever lies within this interval, right? In this case, we're not talking about a proportion. We're talking about a difference. So technically, you can still talk about the true difference in the proportion lies in the interval. But when I go through one today, I'll show you it's kind of better to write it a little bit differently. Right? Because you're directly comparing two groups. So is one group higher than the other group? Is one group lower than the other group? It might be easier to say that. So when we get there, that'll make sense. So far, though, are there any questions about anything that we're doing now? Same stuff, right? Okay. Since my pen is not working and on back order, I have scanned in my answers like I did last week. Okay? So, 2 questions, and then I'm going to give you the assignment. All right? Easy enough. The first one's just about a sampling distribution model and not really anything about a confidence interval. And the second one's a confidence interval. And you know I hate our textbook that gives you breaks it down the pieces for you, because it'll never happen ever on the AP exam. We're going to go with it because I don't have another option. Okay? So number 7, a presidential candidate fears he has a problem with women voters. His campaign staff plans to run a poll to assess the situation. They'll randomly sample 300 men and 300 women, asking if they have a favorable impression of the candidate. Obviously, the staff can't know this, but suppose the candidate has a positive image with 59% of males, but with only 53% of females. All right, so they're giving you 2 proportions. Right? Yes? Okay. Part A takes us way back to chapter 12. What sampling design is his staff planning to use? What type of sample are they going to do? Well, it's going to be a random sample, yes, but it's more specific. They're doing a survey, yes, but I'm talking about sampling methods. Stratified. Right? Why is it stratified? They broke it up into 2 groups, males and females. Right? They're doing a stratified sample. You're like, oh man, that was old. That's the good thing about our textbook. Every once in a while it brings up questions to make you think about stuff. Right? Okay. On part B, what difference would you expect the poll to show? What does expect really mean? In chapter 16 and 17, what was expect? Like the expected value. The expected value was the mean, right? So here, when it's just asking what difference would you expect the poll to show, they gave us 2 percentages, right? What's the difference in the 2 percentages? 6%, right? So that's the difference it's supposed to show, and that's okay. Whereas our sampling distribution model, we said the mean of that model is P1 minus P2, right? We would expect the difference in the population to mirror the difference in our sample. We want them to be similar. So everyone knows where the 6% came from. All right. In part C, of course, sampling error means the poll won't reflect the difference perfectly. We knew that. What's the standard deviation for the difference in the proportion? All right. So how do you find the standard deviation? That long formula we just talked about. So it's going to be, I'll just show you because you guys all know who it is. There it is, right there in the middle, right? Now, please notice my notation. It is going to be very important that you show which group you are subtracting from which, right? Because the orders matters when you're subtracting, okay? You can write 1 and 2 as subscripts if you want to, but that means you're going to have to always go back and define somewhere what 1 is and what 2 is.
Does it matter which one?
You can pick whichever one. It doesn't really matter. I generally try to do it so that when you subtract, you get a positive number. But you don't have to do it that way. It's not wrong to do that way. So AP also generally accepts if you're going to, if it's talking, I don't know, carrots and potatoes or whatever, red and blue shirts, whatever. If they have 2 groups set up like that and you're doing this question, they're going to be okay with you using R and B for red and blue, or C and P for carrots and potatoes, M and F for males and females. They're okay with that. You don't have to define that. They can figure that out. Okay? Unless you're making up some crazy abbreviation for something to explain it. Otherwise, So you need to make note of which we went first. It doesn't matter for the standard deviation because you're adding, but it'll matter in a second. Okay? Everyone good with how I got 0.0405? You guys can do some arithmetic. It's not a big deal, right? Okay. On D, sketch a sampling model for the size difference in the proportions of men and women with favorable impressions of this candidate that might appear in a poll like this. So if we're going to sketch the sampling model, what am I going to draw? A normal model, right? I have the standard deviation from part C, and technically in part B, we talked about the mean, right? Okay. So I'm just going to draw it out. There it is. Super pretty, right? Awesome. That wasn't such a bad one in my notes. It's important, again, to remember, though, that these are differences, all right? So negative numbers are going to be okay. All right, we need proportions. You should have had 0 to, you can have, like, why I was reading negative proportion when they're talking about one thing. Here you're subtracting. Again, we're doing males minus females. So all the positives, right, anything that's positive indicates that the male's percentage is higher, right? Because males minus females, if it's positive, that means the first number was bigger. We got that. But these negatives aren't wrong. It just means that the female's percentage is higher, right? Okay? So make sure you realize that that's not a bad thing. You're going to get some negatives here. It's fine. This is just showing, again, the difference in proportions. So, like, the difference in proportions is going to be somewhere between 2% and 10% for the, like, within one standard deviation of the mean. Okay? Now, the last question is a good question. So we're getting to some good stuff we're going to talk about tomorrow, too. And E, could the campaign be misled by the poll, concluding that there really is no gender gap? If there's no gender gap, what would the difference be? 0, right? And we're going to use 0 a lot when we start doing hypothesis testing tomorrow. All right? But so if there was no gender gap, we would have a difference of 0. So if you go back and look at my notes, you can see this little arrow maybe popping up. So no gender gap, right? 0. So it's within 2 standard deviations of the mean, right? That's not super unusual. So that could totally happen in their sample, and they could totally be misled. That's fine, right? That could happen. So I wrote that. The campaign could be misled. 0 difference is only 1.5 standard deviations below our expected difference, right? If it's in the interval, we didn't do an interval here, but so now it's within a few standard deviations. Do you see how if you're using these estimates of a hypothesis test, right, you can see them, maybe we can make some weird decisions. Questions about that example? Was that difficult? No, not really, right? Okay, one more. Let's do a confidence interval. The Centers for Disease Control and Prevention reported a survey of randomly selected Americans aged 65 and older, which found that 411 of 1,012 men and 535 of 1,062 women suffered from some form of arthritis. All right? A, are the assumptions and conditions necessary for inference satisfied? Okay, so you have to go through and talk about it. So you guys know them, so I'm just going to write it out here. There we go. Independence. Remember, we have to have independent groups, so I just started with that. Men and women are independent groups here. Right? They shouldn't have any effect on each other. No, this one's pretty obvious. You're talking about randomly selecting men and women 65 and older, so and it's arthritis. So if you had arthritis, that shouldn't affect me having arthritis. Yeah, honestly, I didn't know if there was something. No, you can just say that they're independent groups. And if you want to put it in context, which you probably should, and I'm not awesome at that in my notes sometimes, so they get bored, right? Then you could say, because one having arthritis shouldn't affect the other one having arthritis. And that would be okay. Random, notice I say each group, right? It said randomly selected in the question, but each group is randomly selected. 10%, I have 2 different statements. So I have 1,012 is less than 10% of all men, and it should be age 65 and older. That's what the survey's about. And then 1,062 is less than 10% of all women, age 65 and older. So do it twice. And then success, failure, I had 411 men, that's greater than 10, between 601 that were failed, like did not have arthritis, right? So you just show both of them. Can you handle that? It's a little bit longer, but it doesn't take up any more space. Usually I talk about both groups though. We good? Okay. So after we take the conditions now, what are we supposed to say?
All the conditions have been met.
So we can use a yes, normal model.
And a
two proportion, and in this case, in part B, they're going to ask us to do an interval, so an interval. Right? So pretty. If you're doing an interval, you have to say an interval. If you're doing a test, you have to say a test. Okay? So if you're doing a test where you have hypotheses, and you're going to go through and find the probability, like your p-value at the end, say test. If you're doing an interval, say interval. All right. So in part B, create a 95% confidence interval for the difference in the proportions of senior men and women who have this disease. All right? So, I've already checked the conditions and all that. If you go back up here, I already found my actual proportions, right? I divided and found percentages. So, if you're looking at my work here, which one did I probably put first when I was subtracting? I did women. You don't have to do women, but I did women because it's going to be positive. All right? So I did women minus men. You need to show that somewhere in your work. You'll see it in mine. I show it at least once so that you know where that came from. Okay? So we set up our interval. Again, I show right here, I'm doing p hat women minus p hat men. Yeah? So I have a difference. So I actually go through and subtract those. Plus or minus the z critical value is still 1.96. We talked about that. And then I fill in the standard error. Notice, again, this is totally fine. There's different sample sizes. Okay. There's different proportions, so there's different Q's. That's fine. Okay. But I fill it all in. And then you just, or order of operations, if you will, right? And I got an interval of 0.055 to 0.141. Yes. Okay, I'm going to continue for a second. All right. Any questions about where any of those numbers came from or why I put them there? Is it a little more complicated than before? Maybe a little bit. There's more numbers to keep track of. But the concept is the exact same, right? All right. Now, here's where it gets sort of tricky. Interpret your interval in this context. It's still going to start with, I'm 95% confident. You have to talk about your confidence level. I'm 95% confident. We're going to start there. But in this case, think back to that sampling distribution model. We just talked about the positives and the negatives and all that jazz, right? Do you see my interval? My entire interval is positive. Yes? Yes. That means all of my proposed differences are positive. So which group is always greater? Women, right? Because women was first. That's all positive answer. So what that means is that I'm confident that the difference in men and women, because that's what we're talking about, the difference in men and women, is higher for women. So the people diagnosed with arthritis is higher for women since it's always positive. So the way I write this is a little bit different than what you're used to. I just want to preface that. Okay? So I say I'm 95% confident. The proportion of women diagnosed with arthritis is 5.5 to 14.1% higher than the proportion of men diagnosed with arthritis. That just makes sense. If it was negative in this case, and we had it set up the same way, then it would be lower. If it's positive and negative, because that can totally happen.
So wait. Is the limit greater?
If you have a negative through a positive, because that happens all the time. So maybe it's like negative 1% to 5% or something, right? Then you can't say that necessarily one is higher or lower, right? But I can say that the difference, you can just go back to being generic, the difference in the proportions of men and women being diagnosed with arthritis is between this percentage and this percentage. Yes. All right, so, but does that make sense though? I mean, that's what we're talking about. We're talking about people diagnosed with arthritis. So one group is more than the other. That's the part that's going to be a little tricky because we're not used to it. Questions about that? Okay, one end part to this question. Does this confidence interval suggest that arthritis is more likely to afflict women than men? Going back to that 0 idea, right? If there was no difference, we would want to see 0% as our difference. So is 0 in my interval? No. Since 0 is not my interval, and again, we just said that it's higher for women, right? Then there is strong evidence saying that more women are diagnosed with arthritis. It's all going to go back to that 0 idea. When we do hypothesis tests tomorrow, right? We have to have a null hypothesis about differences. What do you think our null hypothesis is going to be? We're talking about the difference in two proportions, and we're talking about null being almost like no change. What do you think it's going to be? Our difference equals 0. All right, so we do hypothesis tests tomorrow. We're going to always start out assuming that there is no difference, and then we'll try to show that there is one. Okay, questions though on the stuff we've done today. Do you feel like you have enough information you could try some of these? Yeah, not so bad, right? Okay.